Hi, 8th grade. Welcome to lesson 6-6, Describe Dilations. By the end of the lesson, I want you to be able to say, I can dilate two-dimensional figures. Solve and discuss it. A landscape architect designs a small splash pad that represented by a triangle ABC. Then she decides to make the splash pad larger, as shown by triangle ADE. How are the splash pad designs alike? How are they different? Look for relationships. How can you use what you know about scale drawings to compare and contrast the designs? So I'm looking for similarities and differences. Hopefully we'll get some participation. Okay, so hopefully you said similar things is that they have the same shape, but a difference would be they have different size. So different size. One is bigger than the other. They both have the same point A. Point A, and that point was at 0, 0. But B turned into D, and C turned into E. So that being said, B was the point 0, 2, and it turned into the point 0, 5. And C was the point 2, 0, and it turned into the point 5, 0. So the zeros stayed the same, but the 2's turned into 5's. Paul wants to make 2 square picnic tables. One table will have side lengths that are 1/2 the lengths of the second table. How do the tables compare? Explain. Well, if it's half the length, one will be smaller than the original, but they will be the same shape. So still the same square. So they'll still have 90-degree angles. Okay, example number 1. The landscape architect designs 2 open green spaces for another area of the park. She designs the larger space so that the length of each side is 3 times the length of its corresponding side in the smaller green space. Where should the architect draw the large green space? So how can you use what you know about scale drawings to determine the space? The architect dilates. Think about when you're at the eye doctor. This is going to be creepy because it's red. But here, we'll have a nice green-eyed person. So their eye is green. And you have the pupil in the middle. That looks like a normal eye. Such an artist. But when the eye doctor dilates your pupil, what happens to the black part? It gets bigger. So that's when the pupil is dilated. It changes the size, but it's still a circle. So the architect dilates the smaller space of the scale factor of 3. A dilation is a transformation that moves each point along the ray through the point starting from a fixed center and multiplies distances from the center by a common scale factor. The scale factor R is a ratio of the length in the image to the corresponding length in the pre-image. So the fixed center of this dilation is the origin O. So we're dilating from the origin. And the image is the same shape, same angle measures and orientation, but different side lengths. So as we can see here, D went from 1, 1 to now being D prime at 3, 3, because we wanted to dilate by a scale factor of 3. So basically what you have to do is multiply by 3. Same thing, we can see A was 1, 2, and then A prime became 3, 3, 6, which is multiplication by 3 both times. So F prime, G prime, H prime, I prime is the image of F, G, H, I after a dilation with a center at the origin. What is the scale factor? The ratio of a side length of F, G, H, I to a corresponding side length in F prime, G prime, I prime, H prime. or I said that in the wrong order, but you get it, is blank. So we need to find the ratio of the side length of the original. So the side length in the original is 1 to the side length in the new, which is 1, 2, 3, 4, 5. So the scale factor is 1/5. Quadrilateral WXYZ is the image of a quadrilateral FGHI after a dilation with the center at the origin and a scale factor of 3.5. What are the coordinates of the vertices of quadrilateral WXYZ? So we have to take each point. So we've got F is at point 1, 1. G is at point 1, 2. H is at the point 2, 2. And I is at the point 2, 1. So now we have to dilate it with a scale factor of 3.5. So we're multiplying by 3.5 everything. So that's going to be W will be 3.5, comma 3.5. X is going to be 3.5, comma 7, because 2 times 3.5 is 7. Y is 7, 7. And WYZ is 7, comma 3.5. So you just took every point and multiplied it by the scale factor. It's going to be the same size, just a different shape. Example number 2. Dilate to enlarge a figure on a coordinate plane. A dilation with a scale factor greater than 1 is called an enlargement because the image is larger than the original figure. So what are the coordinates of the image ABCD after a dilation with a center of 0 and a scale factor of 2? So you identify the coordinates of each image of the vertex of the pre-image, and then you can find the image points of the dilation in the coordinate plane with the center at the origin by multiplying the coordinates of the pre-image by the scale factor. So here, 2, negative 2, multiplied by the scale factor of 2. 2 times 2 is 4. Negative 2 times 2 is negative 4. So the whole time, you're just multiplying x and y by the scale factor. And then you can see it. Same image, same shape, just a different size, different coordinates. So we dilated to enlarge, but now we're going to dilate to reduce. A dilation with a scale factor between 1 and 0 is called a reduction because the image is smaller than the original figure. So what are the coordinates of the image of PQRS after a dilation, the center is 0, 0, and a scale factor of 1/2? Same thing, you just multiply everything by 1/2. So 6 times 1/2 is 3, 10 times 1/2 is 5. 1/2 of 10 is 5, 1/2 of 10 is 5. Same shape, just a different size. A dilation maps point 3, 6 to its image of L prime 2, 4. So that's going to be right here, L prime. Complete the dilation of figure LMN and label the image L prime, M prime, N prime. What is the scale factor? What is the length of the side MN? So we know L is 3, 6, and it goes to L prime being 2, 4. So we need to figure out what can we multiply 3 times what, so we can use, let's use R because that stands for the scale factor, could give us 2. Well, to solve for R, we just got to do the opposite and divide both sides by 3. So R is equal to 2/3. Let's see if that is the same for going from 6 to 4. Well, we know it's going to be 6 times the scale factor R equals 4. So we're trying to solve for R. We're going to divide by 6 on both sides. So R equals 4/6. But if we reduce that, that's 2/3. So that's telling me the scale factor is 2/3. So every time we multiply by 2/3. That's our scale factor. R equals 2/3. So every point, let's see, we've got M is 3, 3. And, excuse me, N is 6, 3. So I want to find the points of m prime and n prime. So I'm going to do 3 times 2 over 3. Put that 3 over 1, multiply straight across. That's 6 over 3, which reduces to 2. So m prime is going to be 2, 2. And we already know that 6 turns into 4. So for n prime, it's going to be 4, we just found out that 6 turns into 2, or 3 turns into 2. So I'll plot these points, 2, 2, it's m prime, and 4, 2, that's n prime. Connect the dots. Same shape, different size, not congruent. The length of side m prime, n prime is 2. M prime, n prime is 2, which originally was 3. Okay, key concept. A dilation is a transformation that results in an image with the same shape, angle measures, and orientation as the preimage, but different side lengths. Since the size is not the same, it is not congruent. Remember, we learned congruent last lesson. When a scale factor is greater than 1, the dilation is an enlargement. And when the scale factor is between 0 and 1, meaning it's a fraction or a decimal between 0 and 1, it's a reduction. So enlargement makes it bigger, reduction makes it smaller. All right, 8th grade, let's say it. I can dilate two-dimensional figures. All right, have a great day.